All right, number 9 and number 10. Okay, here we go with number 9. We graph first. X squared plus 1, so it's a parabola shifted up 1. It's y equals x squared plus 1. The line x equals 2. X equals 2. The x-axis and the y-axis. So the area is going to be all of this in here. And about the line y equals -1, so y equals -1 is down here. And we're going to rotate it around that. That's going to be our axis of revolution. Okay. Well, we could do one of two things. A shell problem or a washer problem. So let's see if I make my rectangle perpendicular to the axis of revolution. Yeah, that should be fine. Alright, so we're going to find the big radius, the little radius. Big radius is top minus bottom, so that's going to be x squared plus 1 minus a -1, so that's going to be plus 1. And then the little radius is going to be the bottom, which is right here. So that's going to be 0 minus a -1, so 0 plus 1. Okay, and then my upper and lower bounds. So the area is going to go from 0 to 2. 0 to 2. This one's kind of easy. It seems a little bit too easy. So the volume is going to be equal to pi integrate from 0 to 2 of the big radius squared minus the little radius squared dx. And I believe that volume is going to be 72.466 units cubed. Just check that one. Make sure you get that. I kind of did that one. I didn't have the answer on my answer key, so I just did that one real quickly on a calculator. So hopefully that's correct. Okay, and then number 10. I'm just going to put 2 on this video. Okay, so the graph. This is the first time we've graphed a ln in a while. ln of x graph passes through 1, so this is just shifted over to the right 2 units. So it normally goes through that point, so we'll shift it over to 3, and the ln graph is going to look like this. X equals 5. It's going to be out here somewhere. X equals 5. The x-axis, so again we're dealing with this area in here, and I'm rotating it around x equals 1, so we're rotating it around this. I don't know why I'm making it dotted. We're rotating it around that. If you do right minus left, and you're going to do a washer problem, you would have to put this in terms of y, so getting it as x equals. Now you could do that, but to do that, to solve for x, you'd have to exponentiate both sides. And if you do that, you'd get e to the y is equal to, the e to the ln undoes their inverses, so that would just give you x minus 2. And if you solve for x, it would be e to the y plus 2 is equal to x. I just wanted to show you that. I'm not going to do a washer problem. I'm going to do a shell problem again for this one. So I'm going to make my rectangle parallel to that. So now I have to find the radius and the height. So the radius for this is going to be this, which is the right minus the left, so x minus the axis of revolution, which in the case is 1, and the height is top minus bottom, so that's ln of x minus 2 minus 0. And then I got to find my upper and lower bounds. Well, I know that that lower bound is 3 and the upper bound is going to be 5. So now when I do the volume of this, it's going to be 2 pi integrate from 3 to 5 of the radius, which is x minus 1, times the height, which is the ln of x minus 2, and then dx. Grab your calculator and we should get the volume is 26.638 units cubed. And again, this is definitely easier to do as a shell problem, but again, if you wanted to do a washer problem and you made your rectangle this way, which would be perpendicular to this axis of revolution, you would have to put this in terms of y, so x equals. Alright, so that's all the volume problems. The last video will just be the cross sections, equilateral triangles, I think right isosceles triangle, and I'm missing one, a square. Alright, that's it.